Introduction to EGCS. In the year 2016, during 70th session of Marine Environment Protection Committee meeting in London, International Maritime Organization took a decision which enforced the new regulation from 1st January 2020, called as IMO 2020 Sulfur Cap. According to this regulation, ships now have to reduce SOx emission. For that, ships need to change to 0.5 weight% sulfur fuel from 3.5 weight% fuel, or by exhaust gas cleaning system, that is EGCS. Use of low sulfur fuel oil. It is expensive but most commonly used method to comply with Annex 6 of MARPOL. Exhaust gas scrubber technology. The exhaust gas from the engine is passed through the scrubber tower where water is showered over it. There are two types of systems. One closed loop system, where fresh water blended with caustic soda is used as a scrubbing liquid which reduces the SOx to 95%. The scrubbing water is then sent to a water treatment effluent emulsion breaking plant, after which it can be discharged overboard. 2. Open loop system, where seawater is used for cleaning of exhaust gases to get control over SOx emission. Now we will see the system overview of open loop EGCS. The exhaust gas cleaning system is designed to remove sulfur oxides from the exhaust gas. As a secondary effect, part of the particulate matter in the exhaust gas is also removed. The scrubber mixes water and exhaust gas thoroughly for maximum contact between exhaust gas and water. Process description of EGCS. When the bypass damper closes, the exhaust gas is led through the jet and absorber. The exhaust gas analysis system in the funnel monitors the quality of the cleaning process and informs the operator. The exhaust gas is cooled in the jet, where an initial SOx and particle absorption takes place. Since this is an open loop system, sometimes referred to as seawater system, the sprayers in the jet and absorber are supplied with seawater. The seawater is supplied to the jet and absorber by the external pumps. The amount of seawater is regulated to ensure efficient SOx removal from the exhaust gas. There is bypass mode provided. The engine's exhaust gas is directed to the bypass damper if the scrubber malfunctions or is switched off. The bypass damper goes to the open position if the scrubber stop button is pressed, or the emergency stop button is pushed, or the pneumatic or electrical supply to the bypass damper fails, or there is an alarm in the exhaust inlet module, or an alarm in another module or device that stops the whole scrubber. The damper control can be manually overridden with a hand wheel located on a crankcase. Later, exhaust gas goes to absorber unit where it gets water sprays from nozzles in absorber and SOx removal of more than 95% takes place. Then exhaust gas passes through demister unit provided at top and out to the funnel. Next we will see how the system monitors the effectiveness of cleaning. For that, the EGCS system is equipped with gas analysis and water analysis units as shown in figure. There is analyzer unit. Number 1 gas analyzer unit, which monitors exhaust gas and measures SOx and CO2 content. Number 2 inlet analyzer unit, which monitors water to scrubber and measures pH, conductivity, turbidity. Number 3 effluent analyzer unit, which monitors discharge water and measures pH, turbidity, pH, ECA mode is provided to be able to use the EGC system both within and outside emissions control areas. Two modes are available: ECA mode and global mode. The mode can be selected with the button on the touch screen. These modes affect the water control settings for the absorber. In ECA mode, the amount of water relative to engine load is higher. The maximum allowed emission limit for SOx CO2 ratio. In ECA mode, the limit is 4.3 ppm%, 0.1% fuel oil sulfur content. In global mode, the limit is 21.7 ppm%, 0.5% fuel oil sulfur content. In ECA mode, more SOx must be removed to be in compliance. This is only possible when the engine load is reduced. If the engine load is above the maximum allowed value for ECA mode, the HMI screen shows a message. If out of compliance, also a warning is given. Depending on the vessel, it may take some time to reduce the engine load. Make sure that the engine load is low enough before entering the ECA area and switching ECA mode to on. ECA mode is set to on. The water control settings and SOx CO2 ratio limit for ECA mode are used. A green border shows around the ECA button. A green message bar on all HMI screens shows that ECA mode is activated. When the ECA mode is set to off, the water control settings and SOx CO2 ratio limit for global mode are used. A green message bar on all HMI screens shows that ECA mode is activated. There are two HMI panels. That is human-machine interface panels provided. One in engine control room and one local panel. Now I will give you brief introduction to icons on panel. Please follow the diagram with me. A. Access to the overview screens of the EGC system modules. B. Access to the lists of alarms, warnings and informations and their status. C. Access to data logger screen. D. Access to system overview, HMI and PLC layout. E. Access to HMI, TP, settings and information. F. Overview button, index of available screens. G. Login button, access to the login window. H. Settings button, access to the settings of the touch screen. I. Utilities button, access to screen printing and tooltips. J. Engine control room panel selection button. K. Local control room panel selection button. L. Emissions control area button. M. Open loop button. N. Stop button, to stop the EGC system. O. Start button, to start the EGC system. P. Overview screen, EXT pumps inlet analyzer. Q. Overview screen, absorber fan analysis discharge. R. Overview screen, jet section. S. Overview screen, inlet section. T. Overview screen, global overview of all modules of the EGC system. U. Back button, to go to the previous screen.